All right, let's dive right into this explainer, because today we're exploring how scientists are achieving something absolutely wild, turning microscopes into literal cinema cameras to film living cells. I mean, imagine trying to shoot a high-end nature documentary, but your subjects are microscopic, constantly moving, and incredibly fragile. That is exactly the challenge biologists face every single day. But as we're going to see, a massive technological leap is fundamentally changing how we capture the microscopic world on film, finally allowing us to watch life unfold in brilliant detail.
So we've got to start with a really crucial question. How exactly do you film a real-time documentary inside a living cell? Because doing this without blurring the frantic action, or worse, completely damaging your cellular actors with intense light, is incredibly difficult. Microscopic actors don't exactly take direction well, and they definitely do not have stunt doubles. You need immense speed to capture the action, absolute sharpness to see the details, and a very gentle touch to keep the cell alive. And for a long time, the scientific community just couldn't get all three of those things at once.
Section 1. The Cellular Documentary Problem. Lighting the Microscopic Stage.
Okay, so this brings us to SIM, or Structured Illumination Microscopy. This was kind of the previous industry standard, and honestly, it was a brilliant step forward. Instead of blasting a cell with a continuous, harsh floodlight, which would literally cook it, SIM enhances detail by shining very specific, patterned light onto a sample. It basically takes a small number of images and mathematically combines them. The huge win here was that it minimized that harsh light exposure. It successfully kept the biological subjects alive and healthy, which, let's be real, is rule number 1 for any good documentary.
Section 2. The Limits of Old Tech, Broken Cameras. Right, so while SIM protected the living cells, biologists still faced two massive frustrations when actually trying to shoot the footage. On one side, you had systems that were slow and precise. These required incredibly tedious calibration of those light patterns, and if they were off by even a tiny microscopic fraction, the whole image was ruined. On the other side, you had fast and flawed. These were simpler systems using random light patterns, but the trade-off was a massive processing bottleneck. It could take agonizing seconds or even minutes just to process a single frame of footage. And obviously, neither of these works if you're trying to capture the fast-paced, real-time drama of cellular life.
Section 3. Enter UBISIM, the AI solution.
So, a team of engineers at UC San Diego finally smashed through this bottleneck with a breakthrough called Unrolled Blind-SIM, or UBSIM for short. Led by Professor Jiawei Liu, they bypassed the clunky hardware and processing times by bringing in artificial intelligence. By integrating AI directly into the image reconstruction, UBSIM processes high-quality images hundreds to thousands of times faster than previous tech. It completely removes the waiting game. Instead of waiting minutes for a single frame, scientists view detailed, fully processed images instantaneously.
But get this, speed isn't the only massive upgrade here. The resulting footage is actually twice as sharp as conventional microscopes. So UBSIM isn't just a faster way to process video, it's practically a 4K upgrade for biological imaging. It manages to take these rapid, low-light snapshots and reconstruct them into stunningly crisp, super-resolution frames, giving scientists the ultimate clarity they need.
Section 4. Physics fixes AI hallucinations. Trusting the footage.
Now we have to address the absolute biggest fear biologists have with AI. Can we actually trust the documentary footage it generates? Because, as study first author Zachary Burns points out, currently many neural network-based models can imagine fake structures when they are applied to new data. This is widely known as hallucinating. And in a cellular documentary, hallucination is a complete disaster. If an AI hallucinates a fake protein structure that isn't actually there, it derails everything. They had to guarantee the AI wouldn't just become a rogue creative director making up its own scenes.
So how do you stop a rogue AI in a lab? Well, step 1, you base the algorithm directly on the actual optical physics of how images are formed. Step 2, you integrate that strict, physics-based approach right into the AI image reconstruction itself. And step 3, you get highly reliable output with zero hallucinations. By strictly tethering its neural network to the laws of reality, they built absolute trust in the footage. What you see is exactly what is happening in the cell.
Section 5. A new era of discovery. Broadcasting live.
So where does all this leave us? We've solved the lighting, fixed the slow processing, and completely eliminated the AI hallucinations. Thanks to UBSIM, scientists can now produce high-resolution, uncompromised video of living cells at up to an astonishing 50 frames per second. Just to put that into perspective, standard cinema that you watch in a movie theater is usually shot at just 24 frames per second. This technology is literally capturing the microscopic world at a frame rate smoother and faster than a Hollywood blockbuster.
Let's break down what this actually means for researchers on the ground. First off, high-resolution, real-time video playback allows them to view detailed images instantly as they're captured, no more waiting around. Because of this, they can now observe rapid, fleeting changes in cellular structures, like the incredibly fast movements of the endoplasmic reticulum, exactly as they happen. Ultimately, super-resolution microscopy becomes as incredibly convenient as simply looking through a traditional, old-school light microscope. It's truly a live broadcast of biology.
So I'm going to leave you with this final thought to genuinely ponder. Now that we finally have the ultimate microscopic cinema camera and we can watch the microscopic world in real time, what hidden secrets of life will we document next? We are standing on the precipice of a brand new era where we can literally watch the mechanisms of disease and the fundamental building blocks of life interacting in high-definition video. The greatest documentary ever made is happening right now inside you, and we finally have the camera to film it.